Hello, everyone, and welcome to the latest edition of our Lightning interview series. As always, we want to make these sessions interactive, as well as, of course, interesting. So as you join us, please do introduce yourself and tell us where you're joining from, and of course, what you do. So as you can see from our first slide here, very excited to do today's interview is with data scientist, author, educator, and very pleased to say frequent ODSC speaker, Serg Masis, who will be joining us in a few minutes. But first, I want to say a few quick words about upcoming events. So quite a lot going on, even though we're well into summer at this stage, doesn't mean you have to shrink your data science, AI, and all these other good events. So kind of skewed towards the latter part of the month, actually, as you can see here. So on July 20th, we have a free webinar on experiment management for uploading your data science workflow. And after that, the actual date on that slide is wrong. It's actually July 26th. Yours truly, myself, will be doing a data wrangling with SQL. And by the way, I'm pretty excited to do this. We did a kind of a precursor to this at ODSC Europe just 3 short weeks ago. And one of my motivations for doing this online virtual training, which I mentioned is about 3 hours, is it doesn't matter if we're looking at, we do a lot of kind of data analysis on jobs for machine learning engineers, for data analysts, business analysts, and SQL is always one of the top skills there, but SQL related to data wrangling for all those given roles. So very excited to do that. And that will also be quickly followed on July 28th, another free webinar on CPUs versus GPUs for your end-to-end data. And as for our conferences, we have ODSC APAC coming up. I think it's must be the 4th year we've been doing ODSC APAC now, and this year is going to be on September 7th and 8th. It is virtual for the most part, but very excited to announce that we will be doing local meetups in Delhi, Bangalore, Sydney, Australia, Tokyo, and I believe Singapore. So if you have any interest in meeting the community in person, we will be putting these on our ODSC APAC website in the next few days. And then, of course, one of our main and final events for the year is we are back in South San Francisco on November 1st to 3rd. So if you like Halloween parties, San Francisco is a great place to be for that. We are doing a virtual component as well, but for the most part, it will be back in person. And we're working on a fantastic lineup of speakers there for that. And as part of that conference, we have our, it's getting to be quite popular. It's our ODSC mini bootcamp. This is great for if you're just starting your data science, data career, or you're just curious. The price entry point is very affordable. And in addition to that, a platform, which I'll talk about in a minute, AI Plus, it's our on-demand training platform. You get free access to that for a year. And you also get access to one of our live training coming up in the month of July or August, September, October, including the data wrangling one I'm doing as well. So if you have a moment, please check that out. And of course, as part of our community service, we're always helping people get started on their journey to data science and machine learning. So in addition to having these career fairs at the conferences we run, we also have an online service right now. It's basically a recommendation system for your career. So if you are looking for a job in one of the data and AI related roles, upload your resume. We're using NLP and machine learning recommendation to match you not only to jobs in our community, but also any AI data related job that's available in the US and around the globe, in fact. And if you're hiring, it's a free service. So just let us know if you're looking to recruit some people in data or AI related roles. And lastly, this session is recorded. We have on this AI Plus training platform, I think there's about a couple of hundred free courses and videos on there as well. So you can log in for a free registration if you're interested in doing a certificate or doing some foundation courses on there. We just had someone that Serge knows very well, John Cron, finishes deep learning bootcamp on there. He's also got a foundation course. So those are all available on demand. So check those out on AI Plus training, as well as other great interview series we've done here. Great. So I believe that's it for housekeeping items. that's it for housekeeping items. I'm not sure what that little blip was, but as always, do introduce yourself. Let us know where you're joining from, and any questions you have for today's guest, post them as well. Serg, welcome to the show.
Hi, nice to talk to you today.
So, as mentioned, Serg Masis is well-known speaker at ODSC and other conferences. And Serg, you've actually got a bit of a history at ODSC. You volunteered a couple of times before you became a rock star data scientist, as well as a book author and educator. So
Yeah, it was a great part of my learning experience to do that. I love the community of data science. I had been in my prior career, I had been also involved in a lot of conferences, and I never had the same sense of commonality. I think that's the word. Well, sense of community.
yeah,
You know what I'm saying?
exactly.
Yes,
Yeah.
yeah. So I love that, and yeah, I also learned a lot from the speakers, other attendees, from the people volunteering with myself, the staff. It was great.
Awesome. And Serg, your current role is climate and agronomic data scientist at Syngenta, and I'd like to talk more about that because that sounds like a very cool role. Also want to get into your book that you published, and I know you're working on some new stuff. But before all of that, just give our audience a background on your journey to becoming a data scientist and where you are today.
Well, it's been it would seem like, okay, I pivoted just recently. I guess it was 4 or 5 years ago that I actually transitioned. But my journey into data science started long before that, acquiring different skills. I always loved data. I just didn't know that my passion would lead me here. I thought I was always a builder, a developer first,
Right.
and data just was part of the process. But I realized that I didn't care as much about building as I did about the data. So anyway, my journey was first started in web development, in app development, in software development, in mobile development, and then eventually took me a little bit into analytics as web started to produce more and more analytics. I started to love that analytics aspect a hell lot more than the building part. And then eventually I just said, okay, hell with it. I'm just gonna, you know, go get a master's in data science and actually just change the roles I get and become a data scientist.
That's fantastic, and I love that because when we started ODSC quite a number of years ago, there were no masters in data sciences in data science, and people were coming from all kind of varied backgrounds, and so not a typical Serg. And so, just a reminder for our audience again to post questions. But now you authored a book titled "Interpretive Machine Learning with Python," and I believe we're going to share that link in a second. And I did get a chance to read a book. Yes, I do read all our guests' books, believe it or not. And I found it very well laid out and quite comprehensive because interpretive machine learning, responsible AI, explainable AI have been topics at our conference and as well as the AI Plus platform for a good number of years now. And I also loved the fact that it was an applied book that you incorporated so many of the great open source machine learning and XAI tools like scikit-learn, Chaplime is all covered in the book. So, but not to get ahead of myself, so tell me a little bit more about the book and who did you write the book for? Who's the audience?
Okay, so the book, I mean, it has some introductory chapters that are about
Yeah.
like leading people into the idea of what is interpretable machine learning or explainable AI and what are the challenges in the space and why is it important. Then it goes into methods for interpreting models. And then there's another section in the book, which is how do you make the models more interpretable and function better in a lot of things you find. So there's
Right.
part of that is like diagnostics and part that has to do with treatment. So they're two sides of the same coin, and I try to balance it out so people get a little taste of both of them because it's a very broad field. And the book is for practitioners. primarily, but it could be for people that are practitioner adjacent, people that manage machine learning engineers, people that work with machine learning engineers from an ethics side or from a business stakeholder side. So it's primarily for the practitioners. So because it comes with code examples. It doesn't have to be it could be an entry level or aspiring practitioner, as long as they have
Yeah.
some foundations.
No, exactly. I found it to be a very approachable book because obviously, as the title suggests, it's for Python. But anybody, even not a Python developer, I thought it was very approachable. And I would also say as well, what I liked about it too is like people think interpretable machine learning, responsible AI. Once I become a practitioner, I'll worry about that later. But there's other topics you cover in the book about bias and all that stuff. So I found it a very good book for what I call architecting machine learning, because back in the day when I was writing code, you would sometimes you'd find out early in your career like not to worry about functional requirements such as security and accessibility and all that stuff after the fact, after you've done your main architecture, that this has to be architected in. So I think even for people just getting started on their data science AI career, it's a good read and something that you should be aware of at the very start. So when you are building your first models and stuff like that, that you've good insight to it. So, but that leads to one of the key questions here. So why is model interpretability or explainable AI, XAI, so important? And sorry for asking all these double-barrel questions. And what are some of the core concepts?
Well, it's really important because fundamentally you want to understand what you're doing.
Right.
Coming from software engineering space, to me it was like I could debug all my code. I could get to the bottom of every problem.
Right.
But the frustrating thing for me, and I had a startup a few years ago, and that's part of what led me here too, because that startup was very data heavy, very data intensive. And to me, it was very frustrating that I had a few machine learning models in it. And if I had a problem, I couldn't find out why I was getting the results I was getting, because there was a hard stop there. It was like, okay, you
Right.
can't get beyond this wall. And for a programmer, that was like, what is going on here? Why can't I get to the bottom of this? So you want to understand the models. You want to understand the models because you want to understand your product, and you want your product to be trustworthy as well. So that's like fundamentally a good reason. Another one is from an ethics standpoint. You have a responsibility towards your stakeholders to, if something goes wrong, they have accountability. You have a level of also fairness. There's a whole host of like ethical concepts that connect to it. Because technologies, also, to be useful, they have to be trusted, and to be trusted, they have to have all these other properties. So you can also see it from that standpoint. I seem to think, like a lot of it get caught in the ethics, but there is a lot of business reasons to actually understand what you're doing from the machine learning standpoint. And as for your second side of your question, as for the key concepts, I think I've alluded to a little bit of them. There's fairness, there's accountability, there's transparency. There's a whole bunch of things within each one, like privacy is a big one, robustness. So these are concepts you keep hearing about because they're all interrelated, So, I mean, sometimes you can't have one thing without another.
No, exactly. And it's definitely a topic we're passionate about at ODSC and AI Plus, and it's something that requires a lot of education and review because, fair AI, as you just mentioned, responsible AI, AI for good. Nobody sets out to create these bias models at the start, but you do have a responsibility, as you mentioned, to understand your models and make sure they are interpretable. And the business use case is so important, because if you look across different industries, whether it's finance, healthcare, you keep hearing these stories of how these models have kind of screwed up basically, and again, not intentionally, but then within a machine learning data science tech department, there is a responsibility to make sure that these models are performing correctly. And now, in addition to that, we have what I call statically trained models. But now, as we kind of get into real-time modeling, continuous integration, continuous deployment, more integrated workflows, the wheels can come off the bus, to use a very technical term, quite quickly. And each type of workflow has its own challenge to interpretability. So it doesn't matter if it's at the data side, data collection side, to feature selection, and then model degradation. So that's so it's super important. And so getting more into the book, Serg, chapter 3, you discuss white box models, black box models, and something I wasn't too familiar with, which is glass box models. So can you give us a little more details on those three and explain the differences between the three?
Well, yeah, for sure. White box models are the ones that have intrinsic parameters that are easily interpretable. They're usually like an equation or something like that, or they have a structure you can navigate with ease, understanding every piece of the puzzle. But at the same time, I mean, a lot of these kinds of models can get so big, it becomes useless endeavor to actually go through everything. It becomes futile. So, you could have a linear regression model that has all the coefficients and everything, but it has, I don't know, like 150 different variables. So can you really interpret it, in the same way that's intended? Not really. Or you have like a decision tree that is like, I don't know, 30 layers deep, the same answer. However, they're still, the coefficients serve another purpose, which understanding how important every variable is to the outcome. So there's that as well. And that's not as easily obtainable with other kinds of models that are far more complex mechanisms. So then what separates white box from black box models is the level of complexity. Yes, there's math involved, but the math is so complex, you can't really kind of disentangle everything. And I say disentangle because there's other properties that involve white box models because they're far less complex. Usually, there's things that are to be expected from that. They're separable. Every variable has its own effects. The interaction effects are, you can separate them easily. They might have linearity. They might have guaranteed monotonicity, which means that the variable and the outcome are always going in one direction. So that makes it easily interpretable. With black box models, that is not a guarantee unless you make it so. So that's a main difference between both. Where glass box models come into question is because glass box models have the intrinsic interpretability that white box models have, with the performance gains you get from black box models. So that's what makes them more promising. And the only reason they haven't probably been adopted, well, other than people not as well aware of them, is speed. So they're not as training is a lot slower because the mechanisms involved to train them. But that's getting better.
Yeah. So does that mean, so glass box models definitely seem to have a future here. But does that mean when we look at these more recent foundational models with billions of parameters, I'm sure that raises its own challenges to interpretability, right? But not necessarily.
Yeah. Plus, all these examples of models with billions of parameters are deep learning models. And that's the thing. Glassbox models, as far as I know, have not gone into that realm of unstructured data. So all the ones you see are for structured data, for tabular data, not for like NLP or computer vision. There's a reason deep learning models perform so well because the kind of data that they have, so multidimensional, so complex and unstructured, means that it lends itself very well to finding these hidden relationships between pixel values in an image or words. So I think we could find ways of actually improving it by learning more of how to work with tabular data, because there's like, for instance, like structures that are hidden in the relationship between words and even pixel values that perhaps we can create from what we're learning through glass box models.
Yeah, and I know, and absolutely, and it's fascinating because we see at ODSC through submissions and talks and workshops we're doing that there's a huge emphasis now on pre-trained models, right? And
Yeah.
A lot of what we're going to be talking about today is about training your own models and your getting interpretability. But somebody else's pre-trained models, whether they're you're buying from a service or one of these foundational models, or GPT-3 or something along those lines, a whole other taking challenge. So maybe we'll circle back on that. But yeah, just continuing on with the book itself, because I did find some fascinating topics in various chapters. In chapter 4, your book covered permutational feature importance, or PFI. Can you tell us a bit about PFI and its relationship with
Sure.
minimal AI?
So say you have a heart disease risk model. So you have all this data, and for instance, you're trying to figure out how different features connect with different levels of risk to heart disease, failure. And so you're saying, well, the younger you are, the less you're going to have risk. So you'll probably see some line like this, right, as it increases. But you want the model, you want to capture what the model expresses in terms of that. So you can easily do that by asking the question. You take every single observation you use to train or test the data, and the model to test. And what you do is you actually change the value for age on each one. So you say, okay, what if this person was instead of 20 years old, 80? What would the model predict? And so and then you average that line out, and so then that's how you get that PFI value. So essentially, like every single possibility, as if you took that 120-year-old and you changed that 120-year-old, let's say if that 20-year-old was 21, let's say if they were 22, and so on, that would be a nice plot. Each line there would be a nice plot, and the average of that's the PFI.
That gives you, as the name suggests, gives an idea of its feature importance, right?
Yes, it's not great in the sense that it's going to come up with nonsensical things, in the sense that the 20-year-old is not going to have the same values for cholesterol than a 60-year-old would, or the same values of some. So it's going to come up with some nonsensical things, which is why some other methods are far more recommended, the PFI. But PFI will at least give you some idea. Oh no, Jesus. You said PFI. I said partial. I thought you meant partial dependence plot. Okay. Permutation feature importance. Permutation feature importance operates also with a permutation. So it's going to calculate also values of importance, but instead ranking them by value of feature, it does it by
importance, exactly.
By importance of the feature. I'm sorry, went off tangent with.
Oh no, that was good, because I do like the fact that in chapter 4, because I think feature selection, looking at your features, it's a really super important part of interpretability. And one thing, again, whether you're experienced data scientists or just getting started, like understanding features, understanding the importance of features. So that's kind of a method I'm pretty fond of myself, and I've had good with it. But
it also has the same issues actually than partial dependence plot, which is why CHAP or other methods are far more important as far as like model agnostic versions methods go for determining feature importance.
Yeah, so let's talk about that, because obviously there's such a huge array of models you can use for machine learning, deep learning, and all that. So again, your book, you just mentioned it. You just mentioned now, actually, model agnostic approach to explainable AI is best. So what are some of the other model agnostic methods you cover in the book? I think you alluded to a few already.
I mentioned, I skipped ahead and I mentioned partial dependence plots, but the better alternative to partial dependence plots is called ALE, plots, a cumulative local effects plot. There's SHAP, which is very famous. It's another one based on game theory. And SHAP has several advantages and also disadvantages. But it's still widely popular. And then there's LIME, which is for local interpretation. LIME would be useful to say, okay, well, why does this particular prediction output that? You know, like you got the prediction for, like, say, the heart disease really high for a patient. You want to figure out, well, why? Why does the model think this person has a high risk of heart disease? And
Right.
so that would be a good way of doing that. Anchors is another good one. It's I think it's also for local interpretation. Difference. I would prefer anchors over LIME because it could pinpoint, like, even not only like the importance of the values but actual thresholds. So it could tell you this person has high risk for heart disease because their their uh, cholesterol is over this amount and their age is above this, and they're of this gender. You know, like it could tell you exactly what kind of thresholds are involved. And then there's also counterfactuals, which is pretty much tells you the opposite. So, you know, what would you have to change to get on the other side of
Right.
the decision boundary? So if the person is risky, how do you make sure they're not risky? That would be a good thing, even for like a credit situation. Like, for instance, this person is predicted to default on their loan. What would make the bank think you're not going to default on your loan? And sometimes it's a very tiny change. Sometimes it's, oh, I need a little bit more collateral. That's all I
This is
do.
scary.
Need.
This is scary.
So counterfactuals are great, and there's many methods for counterfactuals. Yeah, those would be the main ones. There's also ones for uncertainty, which are very good for actual. Now that we're discussing risk and uncertainty are so tied together. So you have anything that involves forecasting, sensitivity analysis. As a former quant yourself, you've probably been aware of it for some time. It's very big in financial services industry. So there's a whole bunch of new methods for uncertainty quantification. Conformal prediction. There's all sorts of methods and all sorts of tools for it. And I highly recommend it if you're predicting something about the future, doing uncertainty quantification, because it's not enough to give a prediction, but tell them, okay, what is your confidence level? You know,
Well,
it
Serge,
doesn't really matter.
I just think we figured out your next talk for ODSC West in San Francisco.
Yeah.
Uncertainty. Yeah, it's a pretty hot topic actually, and not too many sessions on that yet. So that's a really interesting topic. And Serge, you're and again, going back to your book, I like the fact that you mentioned all these methods, but again, LIME and SHAP, for example, you bring it up in your book. There's great open source projects around those two as well, so people can actually try out these methods themselves, run it on their own models, and play around with it. But just going back to a question from our audience, we do have a question from Carlos Andreas, and going back to PFI there, if we can bring it up on the screen. So PFI can be a good initial approach to interpretability in the case of ensemble methods, such as random forest and XGBoost.
Mm-hmm.
But what about complex neural networks? So I'll definitely give that one over to you, Serge.
Can you calculate the importance in neural networks? It
yes,
really depends on the kind of data you have. Like if your data is structured, yeah, certainly. If it's unstructured, it depends what. Like I've used there's this method called integrated gradients. So I've used it on LSTMs for to predict, to forecast with multiple variables. So I can tell with integrated gradients to what extent each time step variable combination interacts and how important they are. So I can say, okay, the last 3 days for temperature are the most important to predict this problem. So I could do it on that level for really complex things. can you do that feature importance on an image? I don't think so, given that the pixels are always shifting. You have like 100 pictures of dogs. You're not going to, the same feature, which is the same pixel precision, is not going to match all the time. So it's a lot more complicated. Feature importance being a global method, using it locally on unstructured data is going to be really tricky, or impossible. More, the same goes with text. You know, like you can't guarantee the same words are going to match, are going to be available in every single sentence. You're right, they're not. So it's not the same issue to figure out that. But you could kind of rank things in terms of, okay, well, this word seems to correlate the most with that. So there's all kinds of measures to do that, to see correlation, but they can't be taken at the same, they're not the same kind of methods you would use for tabular data.
Got it. That's insightful. And Carlos, I hope that answers your question. So we touched upon this, Serg, at the very start of the introduction. We were talking about, the business use cases and how important this is. So now do we understand the importance of interpretability and explainable AI? How do we design our machine learning algorithms to produce more explainable models? Like, what are some of the methods there?
To make the models more explainable? Well,
exactly.
Assuming if it's like a model you could actually switch. If it's, say, you're using a neural network for a tabular data set, you could switch to something that is intrinsically more interpretable, like one of the glass box models we discussed, or something else. But aside from that, there's a lot of methods you could do. Some to the data. For instance, you could do some feature selection, so you're dealing with less features, or you could do some feature engineering, so your features have more of an impact, more of a punch. Like there's all sorts of things you could do there, from discretize things, make them into bins, rather than using like the continuous values for them. All kinds of things, to making interaction features. That's another good one. So there's that stuff, and then there's also regularization. Like, regularization is really important because you can throw a lot of features to the model and just expect it to do its work, but it's not magic. It's just math. So you have to make it easier for the model. And then there's other things you can do within the model to make it more interpretable. Like, for instance, like I put constraints on my models, because otherwise it could do something crazy. Like, for instance, you could do a monotonic constraint, like in the hypothetical example we were talking about heart disease. We could say, okay, one of the constraints is that risk always increases with age. Like, something that may happen very easily is that you only have like one 90-year-old in your data set, and they don't have a risk for heart disease. And so somehow your model tend to think, oh, well, because of that, then it goes up and then it dips. That doesn't make sense. So you put a constraint to ensure that it will continue to increase as people increase in age.
No, that makes a lot of sense. And Serg, another focus area track that's is coming to the front now when you look at academic conferences, like ICML and NeurIPS, and even for ODSC West, we're doing a machine learning safety and security. So some people call it AI safety. That gets into like adversarial attacks, along the lines of data poisoning, model faking out, and things like that. But there is a role within AI safety, machine learning safety, where obviously explainability and interpretability comes in. But that area focuses a lot on making models like more robust, right? Not just designing your models for these very narrow use cases. So I think and your book goes into it, and you've already talked a bit about it, but I think having a clear understanding of explainable AI and model interpretability can actually make models more robust. And I think data scientists and machine learning engineers and others are finally starting to take that more seriously these days. So yeah, any thoughts on that?
Absolutely. Like I equate interpretable machine learning or explainable AI to, like say you're a pilot in a plane, right? And so the way we've been operating planes is as if all we have is, like a few knobs and controls, right? And
Right.
that might work sometimes, and the thing is we're testing this plane only like on clear days with bright blue skies, and that's it. That's our test data set. That's what we're doing. We're not operating it like in the worst data conditions, and that's what we should be doing. We should be operating in the worst case conditions,
Right.
and also with all the possible controls, like the ones you see if you go to a cockpit of a the state of the art plane. That's what we should be operating on, not the like old fashioned planes from the 1930s. And so I think to make a model more robust is to actually throw the worst possible data conditions at it and make sure that it can withstand it. And that's what we should be doing. Adversarial robustness is just one kind of robustness measure. We could also, for other reasons, like tamper with the data, like augment it in many ways to see what can happen, and then measure what kind of. Also, another way, a lot of the methods, like I discussed with uncertainty quantification, even like sensitivity analysis, does all these simulations, does all these different
Yeah.
scenarios, and it can throw off your model. Okay, so you could say you could have a model that predicts, I don't know, like sales based on weather and traffic and a bunch of other things. What if you kind of throw off like the worst case scenario? What could happen? And so to make the model robust is to understand what are the strengths, what is its weaknesses, and how can you overcome the weaknesses.
No, and I think it's fascinating. It's challenging. It's definitely something the industry needs to wake up to for sure. Some areas have, others have not. But it's also, there's a huge opportunity here as well, because we tend to think in role silos, like I'm a data scientist, I'm a data engineer. But think about the whole QA, quality assurance, scripting, testing. There's a whole huge industry around that now, and that job in traditional software is so much easier than machine learning, because you're building in traditional software, you're building a rules based system that was built off a set of system designs and features, right? Whereas the features we're dealing with are quite different. So I see a lot of opportunities for different roles here, like a robustness engineer for machine learning, quality assurance, interpretability engineer. I can definitely see that in the future, that there's going to be lots of interesting roles built around this. But Serge, we've been chatting away here for quite a while now, so I do want to kind of like get to a few remaining questions, because I'm pretty fascinated about your current role as a climate and ergonomic data scientist in your current company. And so that's obviously to do with climate and agriculture. So tell us a bit about that job.
Well, there's an emphasis in the agronomic. It has more to do with the agriculture. People think, oh, you're like predicting the weather. No, I use predictions of the weather. I use weather forecasts, yes, but I don't make them. What I do with machine learning, and my role involves more predicting disease, plant disease, insect infestations, fungi, things like that, that can impact yield of crops. I also predict plant growth, how quickly like your crop will grow, the yield, given certain scenarios and simulations.
Fascinating.
And the idea behind this is to empower the grower, the farmer, to actually make better decisions.
So,
So
without giving away the secret sauce, what are some of the features you look at? Well, obviously weather, you're looking at soil
uh,
quality, all that good stuff.
yeah, so a lot of it is environmental. There's an emphasis in the environmental stuff,
Mm,
which makes climate such a big deal. So a lot of it is environmental. Some of it is genetic, which has to do with the plant varieties and so on. Some plants are more robust towards all kinds of diseases and even climate issues, like too much moisture or too much heat and so on. And then there's also the component of what is called crop practice. Does the farmer till? Do they irrigate? How often do they irrigate?
Right.
How do they space the different plants? Are they well spaced? Is there a cover crop? Is there not? And how much seeds? What is the seed density in this crop planting scenario? So there's so many different things. So there's it's geospatial, temporal data, even satellite imagery, and coming in soon also drone imagery as well.
No, geospatial. Yeah, no, it's a fascinating field, and I grew up on a farm, and our family still has one, so I'm definitely fascinated about this. So I'm definitely going to follow along. But Serg, so people want to get in touch with you. What's the best way to reach out to you? We've already sent the link to your book. Any other resources you'd like to share with our audience before we wrap up?
Well, they can find me easily on LinkedIn. I think I'm the only person with my name there, and the same goes with Twitter as well. I'm easily reachable. Those are like the two main places where they can find me. Yeah, and I like meeting new people too.
Awesome. So yeah, and great. Well, we'd love to have you at ODSC West. A lot of topics I know you can talk about there, and so apart from speaking at ODSC West, what is next for Serg Masis?
Well, I'm currently working on the second edition for this book. In addition to that, I'm also co-authoring one on responsible AI, which kind of focuses on the fairness part. My book does touch on it, but this one is completely into the fairness part. And then I also have another book in the works. It's actually a very interesting project. I think a lot of us. I mean, I came from building, and building, and in data science, we have the two areas of learning, two mechanisms for learning. It's especially important in reinforcement learning. You have exploitation and exploration. And exploitation is great when you know what you're doing, when you know exactly the recipe. But so much of what we do in data science and in science in general is exploration. And I think it's so important to build the skill of exploring. So this book is about play. This book is about doing projects at home for facial recognition, sound classification, playing around with it, coming up with your own ideas of what to do with AI. And so it's about creating that passion in people for data, with their own data. Like people, because people are always, where do I get data? I mean, data's everywhere. Data could be a camera in your living room if you wanted to.
Yeah, and I think you had an interesting expression for that. You call it DIY AI, or was it?
Yeah.
Yeah, no, that's a great term. I like it a little better than citizen data scientist.
Yeah.
Hacking around is where I got my start in data as well. So, Serg, thank you so much for coming on the show. Thank you for being a volunteer at ODSC East way back in 2018, 2019. By the way, for any of our audiences, if you want to get a start at ODSC, you can always volunteer or attend, whichever you feel like doing. And as always, this session will be recorded, and in a couple of days, our awesome team will have this up on our AI Plus training platform, which you can check out. Lots of free stuff out there as well. And don't forget to check out ODSC APAC and ODSC West. So thank you everyone so much. Enjoy your Friday, and we'll see you at the next lightning interview in a couple of weeks. Thank you. Bye, Serg.
Bye.
Bye, guys.